Okay, we'll get to that EOC review in a second. And first off, on number one, all you needed to do was graph it. 3 times 0.8x. 2bx. Cool. Domain. Hopefully you've noticed a pattern here. I don't think we've seen one yet where the domain wasn't all real numbers. And the range wasn't greater than 0. Not yet, at least. Base here is 0.8. The A and the y-intercept are 3. 1, 2, 3. To double check that, you can say trace, graph trace. And there it is at 0, 3. And, well, from left to right, is that getting bigger or smaller? Getting smaller. That's okay. Okay, any questions on number one? Okay. Yeah, do. What is A? It's the vertical stretch. It's the coefficient. If A is 1, it's not stretched at all. If A is 5, it becomes stretched like that. It looks more like an L. Want me to show you? So, say we just get rid of that. Okay. Now say I make it like 10. It should look more like an L. Yeah, it's hard to see from that view, but you can see what happens. Okay, most cars, when you buy them, you drive them off the lot, they decrease in value. You know, you buy a brand new Ford Mustang. I don't know, whatever you want to buy. Camaro, Charger, Corvette, Lamborghini. I don't know what it is, but you go buy it. The second you drive it off the lot, it goes from, you paid $30,000 for it, you drive it off of the car lot, off of the dealership's lot, and it's not worth $30,000 anymore, it's worth about $20,000. Because it's not brand new. Same thing with cell phones. You buy your cell phone for a lot of money, you try to sell it, you can't sell it for that much, you gotta sell it for less than that. But there are a few cars that are collector cars, and over time their value would increase if you kept it in perfect condition. And so here we have a Porsche that your great uncle died and gave to you in 2011. It was worth that much. The value of it increases by 3.4%. How much will it be worth in 2020? What are we doing? Okay, Delonte?
So we're basically trying to find the value of the car in 2012 after the car's value was 3.4% each year. So we're basically creating the exponential function to find that value.
Okay. Okay.
You want me to, okay, say that. Let me get my thing. So then the starting value, well, at first we put the total value, A of T.
A, T?
A as a function of T or A of T.
You mean the amount after T years or days?
After T years is equal to starting value or 87,000. Okay.
What are we doing? Are we just writing the formula or are we filling it in?
I'm going to fill it in.
Okay, so the amount after how many years?
The amount after T years, after 9 years.
Okay.
Because you're trying to find from 2011 to 2020, that's 9 years difference, to equals the starting value, which is 87,000, times the ratio, which will times 1 plus the ratio, and the ratio is 3.4%. and you change 3.4% into decimal form, which would be 0.034. Raised to the ninth power. Solve the thing. That's what I got.
What is it?
117,545.
So you just take good care of your car, change the oil, give it a car wash, don't drive it too much. This collector car increased in value by about how much?
20, 30,000.
About 30K.
Years.
Not bad. You know, you're looking for three things: the time, the initial amount, and the common ratio. Those three things. That's all you need there. And you can plug them in. Time goes over here. The initial amount goes right there. The common ratio goes right there. That's what we did on Wednesday. Questions on either 1 or 2, basically. Shaking your head like it's too easy. All right, take the warm up, set it aside, look at today's notes in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, here's the basic premise or idea that we are using to answer these exponential equations, exponential function equations. So now we're solving equations. If the bases are the same, then the exponents must also be the same, or must be equal. Okay. Now, what worksheet you're looking at, Tia? So, what does that mean? Let's do number 2 first, because that'll, I think, frame it better for you. Number 2 says 4 to the negative 2n is the same as 4 squared. Are the bases the same?
Yeah.
If the bases are the same, then the exponents must be equal. So let's write that. This exponent equals that exponent. Using this rule, we can solve for n, which is what we need to do. It says solve the equation, solve for n. And, you know, real simple, divide both sides by -2. N equals, a bit more clear here. N equals -1. If the bases are the same, then the exponents must be equal. So you can just set up a simple equation. Look at number 1 then, come back to it. Bases are the same, right? So the exponents must be equal. So then x equals 3, done. So that's just the easiest one in the world. Today?
Yeah. Look, he told me 10 minutes before first period was over to get it to everybody.
Thank you. Number 3, are the bases the same? Okay, so this exponent equals that exponent. What am I doing? All I'm doing is writing the exponents. That's all I'm doing. So how do you solve this? No.
Add 3p.
Right? Get the variables over on the left. It's not the only way to do it, but I think having that consistency, doing it the same way every time, will keep you from making small mistakes. So 2p equals negative 2. P equals what? Negative 1. So far, so good? Okay. Now, here's where it gets fun. And I really do think these are fun. These problems, you just got to think like, you got to do some quick setup work as you think. So look at number 4, and what's the problem with 4? Bases aren't the same, so we're going to rewrite them to be the same. The question you ask yourself is, what is the common root? What is the common root? The common root here is 2. In other words, 4 can be rewritten with a base of 2. So how do you write 4 with a base of 2? 2 to the what equals 4? 2 to the second, okay? Then, okay, 2 to the second is the same as 4. So then, just keep the rest of the exponent. Negative 2a minus 2. So we got one long exponent there. One really long exponent with a little bit of a distributive property in there. Okay? And all that's equal to 2 to the 4th. So we keep that one the same. Why? Because the base was already 2. Now can you see the equation that we're going to set up? That equals that. Can we distribute as we write for this first step here? Good. That'll save us some space, I think. 2 times negative 2a. Yep. 2 times negative 2 is negative 4 equals 4. You got several options. What would you like to do? Yeah, I like to do that. Add 4 to both sides. So you get negative 4a equals 8. What did I do? I added 4 to both sides. So I canceled out this one. And 4 plus 4 is 8. I didn't even notice you sneak back in. You're sneaky. Melrose shirt, that's fine though. Who am I still waiting on? Denisha. Okay. Last but not least. Negative 2. Divide both sides by negative 4. Okay, so can I give you some quick little quizzes here on finding the common root? Give you some common root quizzes. If I said 4 and 8, what's the common root? No, it can't be 4 because 4 would be 4, 16, 64. 2. So how would you write that? 2 squared and 2 cubed. Okay, let's do another one. What if I said 3 and 243? What's the common root? 3 to the first, or just 3, and this one would be 3 to the what? What's 3 squared? 3 cubed. No. 27. 3 to the 4th. 81. 3 to the 5th. So, did you necessarily know that? No, but all you're doing with your calculator is 3 to the 3rd, 3 to the 4th, 3 to the 5th. Okay, I got it. That's a pretty hard one. Let's do a couple more that are...
I was going to get that in the calculator.
Guess and check, yep. Like literally, you're gonna do. See what I was doing? You're literally just gonna do that. Is it 4 to the 4th? Is it 4 to the 3rd? What is it? Just type them in. So on that one, you would have said, "Man, I know it's not 3 squared. Maybe it's 3 cubed." No. 3 to the 4th? No. 3 to the 5th? Yes. One more maybe. How about 25 and 625. 5? Okay. Five squared. What's this one? So if you didn't know, and you probably need to make sure. You might have an idea, but you need to make sure with your calculator. What is it? 5 to the 4th? Okay, cool, good. So this is what I mean by finding the common root. Does that make sense? No feedback. I'm going to trust that if it didn't make sense, you would tell me. Okay, let's do number 5 together. What do you pick one? 5 or 6? 5? Okay. 5. Doesn't matter. 5's easy. They're about equal. Number 12. Actually, let's do 5 and 6 really quick. I'm going to make y'all do the whole sheet. I just realized. 2 to the 3rd. Sweet. So, 2 cubed is 8.
Oh, you just did?
Yeah.
Oh,
Yeah.
you just put the rest of the exponent? Oh.
Am I going to trick you if I start distributing right now? 3 times negative p. 3 times negative 2. 2 times 3p. Yes, it's okay if you get a fraction for your answer. Can I just show y'all how I think about these? This is how I want to just not expect you to, I want to train you to think this way. So move the p's to the left. How would you do that? Okay, so what's negative 3 and negative 6? Okay, so just put negative 9p. Let's move the numbers to the right. How am I going to do that? Plus 6. So what's negative 2 plus 6? So in my mind, that's how I do that. That's my steps there. I think I can train you. I don't want to expect you to do that. That's something that you get taught how to do. I want to teach you how to do that. And what's P? Negative 4 over 9, yep. Divide both sides by negative 9. So I did 4 divided by negative 9. You know, if you can start to think of equations like that, that'll save you a good bit of time on the ACT. Number 6. To you? Yep.
For 5, when you solve the exponent, you cancel out the bases, right?
Yeah, we just forget about the bases, basically. Just bring down the exponent. That's it. Question. You find your common root? Okay, so you think 6. So 6 to the what? Yep, did you try that in your calculator? 6 cubed? That's correct. 6 cubed is 216. You know, I don't have that one memorized either. I'm checking in my calculator too. 6, it's not 6 squared, it must be 6 cubed. Yeah, it's 6 cubed. What do we do over here? Do I add anything else over here? No, just leave it as a 2. That's it. Plus 6 on both sides. So 2 plus 6 is 8. Divide both sides by 6. Okay, cool.
Do we really have to start with if it's like 70? And it's no one.
It's not 1.
It's not?
Nope.
Three ain't one.
7. Number 7 is not 1.
It's negative.
Mm-hmm. All right, look down at number 11. Look down at number 11. All right, now. First, I have to introduce you or reintroduce you to this concept. It was in the date for like 2 months straight. My hope is that you were kind of secretly learning it through reverse osmosis. But you know what happens when I do an exponent that's negative? What's that R word? Reciprocal, yeah. So first, here's what you do basically. First you square 3, so that's 3 squared is 9. And then you take the reciprocal of 9. So 9 over 1, take the reciprocal. 1 over 9. Okay, so negative exponent just means after you square it, you flip it.
You said what now? You said
A negative exponent means that after you square it, you flip your fraction or your number. So 8 would become 1 over 8. 16 would become 1 over 16, right? 1 over 10 would become 10. It's an important concept for you to understand on these next few problems. So 1/9 what? Right. So the common root here is still 3. Can you see that? Or you have a lot of options here actually. Or you can make the common root 1/9. Think about what you would do to 1/9. Let's do that actually. I like that better. So this one stays the same, right? But what exponent do you need to do to 1/9 to get 81? So take your calculator, do 1 divided by 9, and let's try some stuff. Now you know that since it's a fraction, it's got to be a negative exponent, because you're going to have to take the reciprocal. So what do you want to try first?
-2.
Try -2. Okay. So let's just stop and think about it first. If I square 9, what do I get? 81. So it would be 1 over 81. The negative tells me to flip them. So what should I get? Should work. Okay. So the negative tells me to take the fraction and flip it. So you get 9, the 2, so 9 squared is 81. See how that works? So your exponent is...
These staff members with Quita Oliver cannot attend in class in Melrose. She should check with the main office. Thank you.
3a equals 1. A equals 1/3.
So how we know? 1 over 6.
Make your base 1 over 16. One over 16 to the what will give you 64.
Oh, we had to find 2, right? 2 to the 4.
To the negative.
Okay, so can we use 1/16 as our base? What I wanted to do is I wanted you to try this. Did you try this? Like to the negative second or something? It didn't work, did it? Okay. So you're right. We can't use 16 here. We have to use a different common ratio or common root. Sorry. So what do you want to use? 4. I think 4 is good. You could do 2 also. 2 would work too. Doesn't matter to me. So 1/4 to the what gives you 64.
6.
You figure it out?
Oh, you said 1/4, my bad. I did
No.
too.
Up, enter. Try another one. Try the second. Okay. Okay, it didn't quite work. Up, enter. Let's try one more here. Let's try 3. There it is. Yeah, because 4 times 4 times 4 is 64. Yep. So it's -3.
So we can't do 2.
You could do, if your common root was 1/2, then what'd you say? -6.
Mm-hmm.
Yep. You'll get the same thing. Okay, so we found -3. We put in the rest of the remaining exponent, and then what do we have to have over here? -2. Because 4 squared is 16. Oh wait, positive or negative? But be careful, because look, what are you trying to make? You're trying to make 1/16. And if you do negative, it's going to flip it.
Oh, we're trying to get 1/16, not 16.
There you go. We're trying to get 1/16, not 16.
So we don't use the -3.
Well, why did we make this one negative, but this one positive? This one, we wanted the reciprocal, right? Can you see that? This one, we wanted to go from a fraction to a whole number. This one, we wanted to stay as a fraction. Okay. All right, just finished all. So -9k. Oh, -3. Equals 2. Kashad, did you get the same answer with a base of a common root of 1/2? Sweet. So exponent negative if you want to go from a fraction to a whole number. Yeah. I'm sorry. Do you have a restroom pass? I have to go with paper. Camping style. Roughing it. What, 17? No. 17's easy. Oh, wait, no, 17, one of them does have the wrong answer choice. I forget which one it is, though. Must be. Yeah, I don't see the answer there. Yep. Hold on, wait. Hold on. Negative. No, I do see it, I think. I see it. It's good. It's a good problem. Okay, any last questions? You know, if it's multiple choice, you can always... never mind. Never mind. All right, go ahead and get to... Where? No. Yeah. Mhm. All right, come see me if you have any trouble. Say when? Come on now. Quit being such a something.